NASA's Perseverance rover completes marathon on Mars. Hook, first 10 seconds. NASA's Perseverance rover just achieved something incredible on Mars. It completed a full marathon. That's 26.2 miles of driving across the red planet, and it happened on July 14, 2026. But this isn't just a distance record. What Perseverance found along the way could change everything we know about life on Mars. Chapter 1: The Marathon Milestone. On July 14, 2026, NASA's Perseverance rover reached a major milestone. It had traveled a total of 26.2 miles, the exact distance of a marathon, across the Martian surface since landing in Jezero Crater in February 2021. That's more than any other rover has driven on Mars in comparable time. The previous record was held by the Opportunity rover, which traveled about 28 miles over nearly 15 years. Perseverance accomplished this in just over 5 years, and it's still going strong. To put this in perspective, Perseverance is driving across a planet that is more than 100 million miles away from Earth. Every mile it covers represents months of planning, thousands of commands sent from mission control, and incredible engineering precision. The rover navigates using a combination of stereo cameras, LiDAR, and autonomous navigation software that allows it to avoid rocks and craters without waiting for instructions from Earth. The marathon achievement is especially remarkable because Mars is a treacherous environment. Temperatures can drop to -100 degrees Fahrenheit at night, dust storms can engulf the entire planet, and the terrain is filled with jagged rocks and deep craters. Perseverance has had to navigate all of these challenges while conducting scientific experiments and collecting samples. Chapter 2: Why Jezero Crater Matters. Perseverance landed in Jezero Crater because scientists believed it was once home to an ancient lake. About 3.5 billion years ago, water flowed into this crater, carving a river delta that deposited sediments and potentially preserved signs of ancient microbial life. The crater is about 28 miles wide and was chosen from over 60 candidate landing sites after years of study by planetary scientists. The delta in Jezero Crater is particularly important because river deltas on Earth are known to preserve organic molecules and biosignatures, chemical signs of past life. When a river slows down as it enters a larger body of water, it deposits sediment that can trap and preserve organic material for billions of years. Scientists believe Jezero's delta could have done exactly the same thing on Mars. Jezero Crater was once a lake bed that filled and drained multiple times over millions of years. Each cycle of filling and draining would have deposited new layers of sediment, creating a geological record of Mars's wet past. By studying these layers, scientists hope to reconstruct the history of water on Mars and understand whether the planet was ever habitable. Chapter 3: What Perseverance Found. In its journey, Perseverance discovered evidence of past water activity, organic molecules, and volcanic rocks that could reveal Mars's geological history. The rover has analyzed multiple rock formations using its onboard instruments, including the Sherlock spectrometer, which uses ultraviolet laser spectroscopy to detect organic compounds and minerals. In July 2026, the rover also completed its first major sample depot, a collection of sealed tubes containing Martian rock and soil. These samples are the first ever collected with the explicit goal of being returned to Earth, and they could contain the strongest evidence yet of whether life ever existed on Mars. The sample caching system uses a complex robotic arm and a series of ultra-clean tubes to ensure that no Earth contamination compromises the samples. NASA has confirmed that at least 10 of the 43 sample tubes contain igneous rocks, which formed from volcanic activity, and several contain sedimentary rocks that were likely deposited by ancient water. Some of these samples show signs of organic molecules, though scientists caution that organics can also be produced by non-biological processes. The rover has also made a surprising discovery about the mineral composition of Martian rocks. Many of the samples contain sulfate minerals, which typically form in the presence of water. This provides additional evidence that Jezero Crater was once a thriving aquatic environment. Chapter 4: The Mars Sample Return Mission. The samples collected by Perseverance are part of the Mars Sample Return Mission, a joint effort between NASA and the European Space Agency. The plan is to send a future mission to Mars that will retrieve these cached samples and launch them back to Earth. The return mission is expected to launch in the late 2020s, with samples arriving on Earth in the early 2030s. This would be the first time humans have ever brought samples back from another planet. The samples will be analyzed in the most advanced laboratories on Earth, using instruments that are far more sensitive than anything that could be sent to Mars. Scientists hope to answer fundamental questions about Mars's geological history, the presence of water, and whether life ever existed on the red planet. The Mars Sample Return Mission is one of the most ambitious space exploration projects ever undertaken. It involves multiple spacecraft, including a lander, a fetch rover, and an ascent vehicle that will launch the samples from the Martian surface into orbit. A separate orbiter will then capture the sample container and bring it back to Earth. Chapter 5: Oxygen Generation and Future Human Missions. Perseverance is also testing new technologies that could help future astronauts explore Mars. One of the most important experiments is MOXIE, a device that converts carbon dioxide from the Martian atmosphere into oxygen. In its tests, MOXIE has successfully produced oxygen multiple times, proving that future astronauts could generate their own breathing air and rocket propellant on Mars. This technology is critical for human exploration of Mars. Bringing enough oxygen for a crew of astronauts from Earth would be prohibitively expensive and impractical. Being able to produce oxygen on Mars would dramatically reduce the cost and complexity of human missions to the red planet. NASA's Artemis program aims to return humans to the Moon as a stepping stone to Mars. The technologies being tested by Perseverance, including MOXIE, will be essential for making human Mars missions a reality. Engineers are already working on scaled-up versions of MOXIE that could produce enough oxygen for a crew of astronauts. Beyond oxygen generation, Perseverance is also testing a terrain relative navigation system that allows the rover to compare its position against orbital maps in real time. This technology will be crucial for future landing missions, including the Mars Sample Return Lander and eventual human missions. Each precision landing brings us one step closer to sending astronauts to the red planet. Chapter 6: The Global Effort Behind Perseverance. Perseverance is not just a NASA mission, it's a global effort involving scientists and engineers from dozens of countries. The rover's instruments include contributions from France, Spain, Norway, and the United Kingdom. The SuperCam laser, for example, was developed by a French-American team and can analyze the chemical composition of rocks from up to 23 feet away. International collaboration in space exploration has never been more important. As NASA plans for future Mars missions, partnerships with ESA, JAXA, and other space agencies will be essential. The Perseverance mission demonstrates that when nations work together, they can achieve what no single country could accomplish alone. Conclusion and call to action. NASA's Perseverance rover has proven that robotic exploration can achieve extraordinary things. A marathon on Mars might sound like science fiction, but it's real, and the discoveries along the way could answer one of humanity's biggest questions: are we alone in the universe? The rover is still exploring, still collecting samples, and still making history every day. If you found this video interesting, smash that like button, subscribe for more science and technology content, and hit the notification bell so you never miss a breakthrough. End.